Vertical stretches and compressions. So we've talked about shifting left, right, up, down. Quick kind of reminder here. Previous video, vertical shifts, that's going to be adding or subtracting on the outside of the function. It's exactly what you think it would be. Plus is up, minus is down. Horizontal shifts, on the other hand, those happen inside the function and they're the opposite of what you'd expect. You would be subtracting h on the inside if you're moving to the right and adding if you're moving to the left. That's what we've talked about so far. Now let's talk about vertical stretches and compressions. Stretching and compressing a graph is kind of what it sounds like, right? If you have a graph like this, we can make it wider. Oh, that didn't make it wider. There we go. We can make it wider. We can make it skinnier. That's what stretching and compressing the graph is, making it wider or making it skinnier. Now, there's also horizontal stretches and compressions. I refuse to talk about them. They're so confusing and unnecessary for us to talk about. So we're just talking vertical stretches and compressions. All right. So with vertical stretches and compressions, this has to do with multiplying the function by a scalar. If you multiply by a value greater than 1, then, so I'm taking an a value, which we've determined is greater than 1, multiplying the original function f of x by it, this creates a vertical stretch. By a factor of a. What happens is your point, your original point, x naught comma y naught, will get relocated. Same x position, but now we multiply the y value by whatever value is out front here. And that makes sense, right? Y and f are the same thing. So if y is now equal to a times f, that makes sense that you're multiplying that a value or the y value by a. So if your a value is greater than 1 and you multiply the outside, you are going to stretch your function by a factor of a. On the other hand, if you have a value between 1 and 0, 0 and 1 is what I should have said, 0 and 1. These are all one take, guys. These videos, I don't do multiple takes on these videos. I am not that much of a professional. I am making far too many videos. So you just get to enjoy the rawness of it. I hope you appreciate it. Mistakes and all. All right, y equals a times f of x. It's the same thing, but what we're saying now is that the value out front is between 0 and 1 as opposed to being greater than 1. Let's just make an assumption that the a value we're talking about is positive. We'll talk about what happens if it's negative in a later section. Anyway, if you take that a value out front and you multiply it by the function and it's between 0 and 1, instead of stretching it, it's going to compress the graph. Now, here's where there's controversy, and I know everyone loves controversy, so let's talk about it. I'm going to word this as saying it's a vertical compression by a factor of a. I am mentioning this to you because there is a disagreement on what we should call a compression. Some books, instead of saying that it's been compressed by a factor of a, some will say it's been compressed by a factor of 1 over a. I don't know. I don't like it. I think it's confusing. So that's not the wording I use. And you don't need to worry about Alex because Alex isn't going to fool you. Don't worry. It's the same math here. You're just multiplying the y value by a. The only difference here is that you're making the y value smaller in the second case, and you're making the y value bigger in the first case. You make it bigger when you multiply by a number greater than 1. You make it smaller when you multiply by a value less than 1. Oh, man. You can almost read that there. All right. So we're going to graph some functions here. I'm going to cheat and move this guy down a tiny bit. You can leave these ones. All right. Our base function here is the absolute value of x. If you'd like to refer to an earlier video, you can look at the library of base functions. Annoys me that that thing doesn't want to lie perfectly, but I just gonna have to let it go. All right, that's the absolute value of x. That is our original function. Let's go ahead and take a few points. Actually, not that point. Let's take this point here, this point here, and this point here, and transform those particular points. So that's the point -3, 3, 3, 3, and 0, 0 is what I should have put here. Okay, give me just a sec. I'm gonna lay this all out for us. Give me a sec. All right, what I've done over here is I've taken each of these points and we're just going to talk about how they move. But I wanted to put that all down there so you didn't have to sit through me doing it. There we go. All right, so we're taking these points. The first function we're looking at is 3 times f of x. F of x is the absolute value of x. So 3 times f of x is 3 absolute value of x. This is stretched by a factor of 3. That means that all of the y values are being multiplied by 3, which is why when I originally chose a point that was over here, I realized I couldn't, because if I have 6 and I multiply by 3, it's 18, and the y value will be off our graph. So we are multiplying all of these y values by 3. This becomes -3, 9, 0, 0, and 3, 9. So 0, 0, this guy just stays in the same place. And there we go. So if you look at this green, it's a lot skinnier. So it's been stretched vertically. When it's vertical, when it's stretched, it's just going to be skinnier. And we're going to make a small change here, and maybe I can make this change on the worksheet before you guys do it. Let me pause and actually do that right now. All right, it just did several things, but one of them was changing this on the worksheet, so yours should look right from the get-go. 1/3 f of x. Here we have a number being multiplied outside the function. That's how we know it's a compression or a stretch. 1/3 is less than 1, so this is going to be a compression. In a case like this, some books may say, like I was mentioning up here, that it's a compression by a factor of 3. I just, let's just say it's a compression by a factor of 1/3. So that means that this function is going to be 1/3 absolute value of x. 1/3 absolute value of x. And we are multiplying all of the y values by 1/3, which is why I changed it to 1/3, because those numbers would not have been pretty. 1/3. So we get the point -3, 1, 0, 0, and 3, 1. So can we see what it's the difference here with the 3 absolute value x, we are taller than the original graph, and then with the 1/3 x, which I did in blue instead of purple. Oh well. With the 1/3 x, it is wider. It is like fatter, skinnier and taller, wider, fatter. All right. So we talked about vertical shifts already. We've talked about horizontal shifts. Vertical shifts, just quick summary here. That's when you're adding on the outside or subtracting on the outside. This is up. This is down. Horizontal shifts happen on the inside. It's the opposite of what you think. So f of x minus h is right h. F of x plus h is left h. And now we have stretches. So these happen outside the function. They only affect the y value. So you're multiplying the y value by a. Oh, that was Notability shutting down. Oh, that's Reflections. Well, you guys saw what was here before Notability crashed on me. I'm not gonna, well, I'll pause it and rewrite it. Hold on. All right, I think that's what we had there. For vertical stretches, again, we're looking at a times f of x, so we're looking at a number out in front. It's on the outside of the function. It only affects the y value. We multiply the y value by a. If the number out front is bigger than 1, then it is a stretch, and if the number out front is less than 1, it is a compression. So examples of stretches, if I had like 7x cubed, 7 is bigger than 1, that would be a stretch. 5 square root of x, 5 is bigger than 1, that would be a stretch. 9 absolute value x, 9 is bigger than x. So those would all be stretched. Something like 1/3 x cubed, that's a compression. 2/5, which is smaller than 1. 2/5 square root x, that would be a compression. 1/4 absolute value of x, that would be a compression. So we're just looking at that number out front and seeing whether or not that number is bigger or smaller than 1. All right, in our next video, we'll talk about reflections, and that will be all of the tools we need to put it all together. I'll see you in another video. Bye.